Hi there. Now in this video what I want to do is show you how you go about deriving the results for differentiating the trigonometric functions sec x, cosec x and cot x. So let's start with y equals sec x, which is 1 divided by cosine x. So the reciprocal of cos x in other words. And to differentiate this, what I'm going to do is change this to cos x all to the power minus 1. And I'm assuming that you're familiar with the chain rule. That is, essentially what we're doing is that to find dy by dx, we find, say, dy by, say, dt, as long as we multiply it by dt by dx, where y would be equal to, in this case, t to the power minus 1, t to the power minus 1, where t is cos x, okay? So t equals cosine x. The chain rule then. Now, in order to get then dy by dx, we've got to, first of all, find dy by dt. So if I differentiate t to the power minus 1 with respect to t, that's going to be minus t to the power minus 2. So that's minus t, but t is cos x, so that's cos x, all to the power minus 2. And then we have to multiply it by dt by dx. So if I differentiate cos x with respect to x, that's going to be minus sine x. So tidying this up, what we've got here is a positive value, and this is 1 over cos x all squared multiplied by sine x. I'm going to split this up to just 1 over cos x, and then I've got another 1 over cos x times the sine x, and I could write that as sine x over cos x. Okay, so we've got 1 over cos x all squared multiplied by the sine x there. And then 1 over cos x, well, that's the same as sec x. And sine x over cos x, well, that's the same as tan x. And so this is a familiar result. You should find it in your formula book. Otherwise, just try and learn that one off. Differential then of sec x with respect to x is sec x tan x. Let's just underline that, okay, as that result. Now when it comes to differentiating cosec x, it's a very similar technique to what we've just done here. Only cosec x is the same as 1 divided by sine x. You might want to pause the video at this stage and then just carry on, as I say, in much the same way as we did here, and then you could check your answer at the end. So just give you a moment if you want to do that, to pause the video. Okay, welcome back then if you had a go. So we write this now as sine x all to the power minus 1. And we're going to need to use the chain rule again to work out what dy by dx is. Only this time we're going to have y equals t to the power minus 1, same as we had before, but this time t is going to be equal to sine x. Okay, so we've got that. So to find dy by dx, it's going to be dy by dt, y equals t to the power minus 1. So as before, that's going to be minus t to the power minus 2. But t is sine x, so it's going to be minus sine x all to the power minus 2. Then we need to multiply it by dt by dx. And if I differentiate sine x with respect to x, I get cosine x, or cos x for short. And I tidy this up much the same way as I did over here. This is minus 1 over sine squared x, but I'm just going to take one of those sine x's, just put it like that, and then the other sine x, I'm going to put it underneath the cos x. So you've got cos x over sine x. And so we end up with minus, and 1 over sine x is the same as cosec x. And then cos x over sine x, well, that's cot x. Okay, so that again is a result that you'll no doubt see in most formula books, but it's there should you need to prove it. Now in the last one we've got y equals cot x, and this is handled differently to what we've done up here. This is the same as cos x over sine x, and because we've got two functions of x here, we need to use the quotient rule. As a brief reminder, remember if you've got y equals u over v, where u and v are functions of x, in this example u would be cos x, v would be sine x. Remember the quotient rule was dy by dx equaled the bottom of the fraction, v, multiplied by the differential of the top of the fraction, du dx. Then it was minus u times dv by dx, all divided by v squared. Okay, so it's that I'm going to use here. So when it comes to differentiating this, we've therefore got dy by dx equals, and I'll just draw a division line here first of all. Okay, what we've got then is the denominator squared, so that's going to be sine x all squared, or I could write that as sine squared x. And then you've got the denominator times the differential of the numerator. So denominator is sine x, and we multiply this by the differential of the numerator, the top of the fraction. Differential of cos x with respect to x is minus sine x. And then we do minus top of the fraction, u, that's cos x, times the differential of the bottom of the fraction. So differentiating sine x with respect to x gives us cos x. Okay, so just border this off down here and tidy this up. So we've therefore got dy by dx equals, and this is minus sine squared x, this is minus cos squared x. So we'll just pull out a negative there, and then it becomes minus sine squared x, and then plus, okay, cos squared x. Okay, and all of this is divided then by sine squared x. And should be familiar with the identity sine squared x plus cos squared x, that's 1. So we end up with negative 1 over sine squared x. So minus 1, all divided by sine squared x. 1 over sine x is cosec x, so 1 over sine squared x will be cosec squared x. Not forgetting that negative though, we end up with minus cosec squared x. And that is the standard derivative then of cot x. Okay, well I hope it's given you some idea then on how to differentiate those three trigonometric functions. And so thanks for listening, and I hope you found that of some value.